All right, we're going to continue on with some talks about debris flows. And I'm going to try and use this pointer here. Can you see that on there? Yes. Yeah, okay, great. First, I'd like to acknowledge my co-authors, Nancy Calhoun, also from Dogami, Jason Keene, and Francis Rangers from the USGS. And so we're all very aware of the 2020 Labor Day megafires that happened, and these burned a huge amount of the Cascades. But 4 months later, in January of 2021, we had an atmospheric river over the Eagle Creek fire, which happened in 2017, and that rainfall event caused a bunch of debris flows in the gorge. And unfortunately, a fatality with one of these debris flows, and this is a photo from ODOT of that fatality. And both of these events kind of combined was a big wake-up call for the need for research to understand these post-fire debris flows and risk reduction in these fire regions, especially in Western Oregon. So, was very pleased that after these events, many teams were formed, and these are just some of the teams that I'm aware of, that started doing research on post-fire debris flows in Western Oregon. And we just heard from Ben Lashinsky and his team doing some of the research there. But what I'm going to talk about today is the data that Dogami has been collecting after storms when we go out in the field and see if debris flows have happened or not. So one of our goals is to update the USGS likelihood model for regions of Western Oregon, and I think Francis Rangers is going to talk a little bit more about this, but this is the general idea. This data set is from Colorado, and the idea here is we go out in the field after the fire, after storms, and we collect data, we look in the channels, and take observations on whether or not debris flows have happened. So these blue dots on here are channels that did not have debris flows with associated rainfall intensities, and then the red circles are when debris flows happen. And the idea is that you can establish these thresholds of rainfall intensity above which we would expect to see debris flows and below which we would expect not to see debris flows. And these are the fire locations: Eagle Creek, Riverside, Beachy, Lions Head, Holiday, and Archie that we've been collecting this data on so far. And we are going to expand that to likely include Cedar Creek. So why do this? Well, one of the goals is to help issue these warnings better. And we just heard from Andy Bryant, who's been putting out these warnings, and don't get me wrong, they've actually been doing a great job. And this is an example of one of those outlooks that Andy was talking about. And you can see on here on January 5th and 6th, they said, well, we could have flooding and debris flows. And actually, we did. And here is a photo from Multnomah County Sheriff's Office of a debris flow that came out in the gorge and unfortunately buried Highway 30 and went on to Interstate 84. And I'll talk a little bit more about this event in just a second. So what do we do? So we're actually in the third season now of collecting data. And we go out in the field and we drive these roads and we stop where the roads intersect these channels, and we get out and we look and we take observations of, yes, did a debris flow occur or no? And in some cases, other things happen, like maybe a flood came through, a flash flood, or a lot of water came through, and we'll take observations on that, collect all this in our ARC collector online, on our mobile device, and then all that data goes back home with us. We bring it up in our GIS, and then we can add some more additional information to that. So, what are some of our results that we found so far? Well, in the first season, 2021, we collected 315 points. There was 35 debris flows that season, 19 other types of events, and 226 channels that had no response. The next year, 21-22, another 300 some odd total points collected. A little less debris flows, 23 debris flows that year, but 34 flood scour and other types of events, and then 233 non-response. And then so far this year, we've only collected probably about 20 points so far, and there were 2 debris flows that we've witnessed so far this year. So pretty calm year so far this year. So let's dig into these seasons a little bit more. So first year, 2021, we had several our standard type of winter storms that we have here in Western Oregon. But on top of that, we had one strong to extreme atmospheric river on January 12th and 13th. And all these storms combined caused several small debris flows and other flood type events throughout kind of central and southern Oregon on those fires. But we had many, many large debris flows in the north. And this image over here shows that atmospheric river coming from, here's Hawaii down here, here's that atmospheric river. I've outlined Oregon here. And you know, unfortunately, Eagle Creek sits about right there and is kind of right in the target of this big atmospheric river. Over here on the left, this is a monitoring station that we have collaboratively with the USGS. This is actually in the West Hills of Portland, but you can really see this event coming through, passing Portland and then going up the gorge. What you can really notice, this is about when the debris flows occurred. Ooh. Back up, where this red arrow is. But what you can really see is, maybe using my fingers, not the greatest, is this cumulative rainfall over here. Sorry. One more. The cumulative rainfall over here really increasing over these couple of days, and then this spike in intensity, that's this green spike right here, where we had a really high intensity rainfall, and that's very likely when most of the debris flows occurred. So let's look at the gorge a little closer. This is our landslide inventory, our LiDAR-based landslide inventory in here. Really, you can see a lot is happening in here from a mass wasting perspective. There's also a very long history of debris flows in here, almost 100 years worth of events. But really what's kind of noticeable is that we've had pretty big debris flows the last 2 years in a row, and then some smaller events this year. Many of these events are kind of focused in this Dodson-Warrendale area. You can see this very large fan complex that's kind of pushed out into the Columbia River. And these red events are historic events. This is Tumalt Creek. This is from the 1996 events that actually buried the highway, the rail, and then went into the river. And this is the Levens Creek event from 1996. Well, let's look at what happened in the 2021 events. What I'm going to do is take you kind of on a helicopter ride starting from down here at the deposit area and then work our way up to where these things initiated up here. Okay, so here we are down at the deposit. Really what I want you to notice is, as this thing left kind of the channel area, how much it spread out. Fans, it forms this fan shape. You can see kind of this coarser material all along the front here. Unfortunately, Highway 30, you can see it coming this way, is underneath this whole deposit. And we actually closed part of Interstate 84 as well. It's a little difficult, though, to tell how deep this thing is. So this next slide I'm going to show you was several days after, a week after, as ODOT was cleaning their way through here. Here's Nancy standing next to all these giant boulders that were pulled out of this deposit. And then as they're cutting their way through, this is the on-ramp entrance to I-84. Actually, Highway 30 is still on this side of the trees here, but put this yellow line across here so you can see generally how deep this is. You know, I'm 6 feet tall. If I stand next to a truck like this, my head's probably here, so this has got to be at least 8, 10 feet deep in there. And we've stood over here next to these trees, and you can see a nice mud line on top of the trees, on the tree trunks, that is probably 12, 13, 14 feet deep. So a very big event that happened here with very large boulders. So working our way upstream, now we're in kind of the main transport area of the event, and a couple things I want you to notice. One is, look how wide this swath across the landscape is, especially compared to this little creek that's in here. The other thing is, you can really see like all the scour that took place in here. So this debris flow was still bulking or getting larger as it was passing through here. And you can see these beautiful debris flow levees left on each side of this channel in here, especially these really big boulders and very large woody debris left behind as this thing passed through here. And then finally, up to the initiation part. So we were looking at the deposit, which was way down here, and then we were looking at the transport zone kind of in here. Now we're way up on the top where these things initiated. I want you to notice a couple things. One, how steep it is up here. It's very steep. In fact, there's little waterfalls here, so near vertical in places. The other thing is you can see that all of these trees are dead in this area here, still standing and just kind of looming over the slopes. I'll turn on these yellow areas so you can see at least 3 of the spots that look like they initiated and could have contributed to this debris flow down Levens Creek. What I'm going to do is take this photo and kind of turn it on its side so we can look at these initiation sites a little closer. So here we are, and I'm going to circle kind of where these things initiated. And what I want you to notice is both of these sites over here initiated what we call in the channel. So they have kind of likely channel bed failures that initiated here and here. And then, and then this one over here actually looks like a shallow landslide that initiated kind of on a colluvial slope. And actually the channel is over here. So this one did not initiate in the channel. And to add to that, really looks like there may have been some erosion, overland flow and erosion above these 2 sites, but we're really not seeing that on this site. And what that's doing is these sites are really close together, but we're seeing these 2 kind of processes happen, which makes it really complicated for us to figure out what exactly is going on in these post-fire environments. So I'm going to have to speed up a little bit here, but the next season we had, again, several strong storms and 1 atmospheric river. This is that atmospheric river, again, aimed here at Oregon. Again, we saw several small debris flows and several bigger debris flows up north. One thing about this atmospheric river this year, it occurred almost a year later, but we don't see these rainfall intensity spikes down here. But one thing we do see is this rapid warm-up. And there was some snow on the ground, and you know, this really warm, moist air coming down here from Hawaii likely melted some of that snow and contributed to the debris flows that occurred this season. This one's in the Fish Creek watershed along the Clackamas. There's Nancy for scale. a couple more that occurred in the riverside, and here's Highway 224 down here at the bottom. These two look like they initiated via shallow landslides. And then this year, so far, you know, not a lot has happened. We did have kind of one medium-sized storm in November. We had a big debris flow along Highway 224 and several other small ones. This is that one that Ben had showed and came down and buried Highway 224. And this is a couple days later as ODOT was cleaning through here. You can really see the scour in this channel here. And then, you know, at the same time, during the same event, some smaller stuff came down out in the gorge. Ben showed this picture. Here's Nancy on Tumult Creek, and then Levens Creek maybe had some flood scour with some fine grain material that came out there. So, lastly, just to kind of summarize this all together graphically, what we kind of thinking may be happening here. So, on the x-axis we have time, on the y-axis we have the general debris flow hazard. And you know, in Western Oregon we already have a background hazard that's well above none. We have debris flows all the time without fire, but what happens here is, you know, at some point in time we have a fire, and in these kind of drier climate areas where this process, this post-fire debris flow process, has been studied for several decades, what they generally find is that that hazard kind of climbs from wherever their background hazard level is, climbs very quickly up to high, and then usually during maybe the first year or two, you have a big enough rainfall event, they have post-fire debris flows, and then that hazard curve kind of quickly comes back down to their background hazard rate. And just like Ben and others have been, if we look at what happened in Eagle Creek so far, so we had a fire 2017, and then we had several seasons go by where almost nothing happened, and then finally in 2021, big debris flow events, 2022, more debris flow events. And as Ben mentioned, you know, many studies have shown that we have this increased landslide incidence, maybe in the years following timber harvest, or others have shown this for post-fire as well, that kind of in that decade following those activities or events, we have increased landslide hazard. And all of this is making us think, you know, our hazard curve may look something more like this. It may take it a little longer for it to get up to where it's going, and then once it's up there, it might stay up there for quite a while. And we're not sure exactly what this is going to look like, if it's going to quickly come back or how long this is going to go, but it's definitely looking like it might be different than what we see in these kind of drier climate areas. And with that, just some thoughts. You know, we really think wildfire does have an influence on post-fire debris flows in Western Oregon, but it's probably different than what we see in these drier climate areas. You know, one thing we're not seeing is this kind of widespread slope rilling, and I think Francis is going to show you some examples of that. Also, all this discussion about delayed mortality in trees and delayed regeneration because of the high burn severity areas are bigger. All of this, plus all this past research, is really making us think that our hazard may last quite a bit longer than it does in these other parts, drier regions. All this is really indicating we need continued research. We need to keep collecting data out in the field after storm events. We need to connect these to the precipitation and the snow melt and look at the various rainfall intensities. I think that was all I had. Yeah. Happy to take any questions. Do I have time? Okay. Yeah. Question was, do we have any estimates on speed? I do not. Michael says 25 miles per hour. He's actually going to give one of the talk coming up soon, Michael Zimmerman from ODOT. Around 25 miles per hour is his guess. So really moving. Yeah?
When doing your field review, is your team looking at the initiation point of these slides? And if so, are you determining if they're road related?
Yeah, that's great. So question was, when we go out and collect field data, are we looking at the initiation sites, and are they related to roads? And, you know, getting to the initiation sites is really difficult, especially with this kind of mixed private and wilderness and very steep ground. And so we haven't been getting up there as much as we need to. And one of our hopes is that going forward, we can send drones up to actually look at those initiation sites and collect more data about it. So, great question.
Hello, thank you for the excellent presentation. And so I wanted to ask a question about the Eagle Creek fire in particular and this debris flow. It was so striking, the size of those boulders, and that, I mean, those are heavy. I mean, you could probably tell me how much they weighed. I'm sure it's like thousands of pounds, and that takes an incredible force. But this is a relatively small watershed. I find it really interesting that, you know, we tend to think of like the Clackamas River at flood stage moving something like that, but I mean, if you look at just the size of this picture here and the size of that watershed, it's just, where did all that water come from? How could there be that much water? Was there any indication that there was like impounding, building up dams that then created a force that moved boulders that size, and a lot of them? I mean, the fine debris wasn't that surprising to me, but yeah.
Yeah, good question. So I think your question is, was there anything else that may have happened in there that contributed to the ability to move such big debris? And, you know, as far as we can tell, not in Levens Creek, although we've definitely heard about other drainages in the Columbia River Gorge that may have had shallow landslides that have blocked that channel, had a little lake buildup and a blowout that, like the Tumalt Creek one in '96, I think I've heard that that may have happened there. And that one went a lot further, so it probably had a lot more water in it, which helped it go further all the way into the Columbia River in that case.